Hey everyone! Today, we're going to dig into something that's a really big deal for anyone who writes software, the philosophy behind design patterns. We're going to explore how they help us go from just writing code that works to actually building code that's meant to last.
All right, let's just jump right in with a question, and I guarantee you've asked yourself this at some point. You start a new project, everything's clean, it's beautiful, it makes sense, and then fast forward 6 months and it's a complete mess. How on earth does that happen every single time?
Well, there's actually a name for this slow creep into chaos, and it is so perfect. It's called the snowball effect. And honestly, it's the silent killer of so many good projects.
So, to kick things off, we are going to break down this exact problem, because once you really get your head around it, you can finally start to fight back against it. So here is the core idea. A tiny little decision made on day one. A small shortcut, maybe a dependency you weren't sure about. It seems totally harmless, but as the project grows, that decision starts picking up speed, collecting more and more complexity, until bam, you're buried in an avalanche of technical debt. The real difference between a junior and a senior developer is knowing how to stop that snowball before it even starts rolling. So how do we stop the snowball? Well, that brings us to the most important concept we're going to talk about today. Understanding that a design pattern is a blueprint, not a recipe. And that distinction, it's everything. You see, seasoned professionals don't just reinvent the wheel for every single problem. When they run into a challenge they've seen before, they reach for a toolkit of proven, battle-tested solutions that have been figured out over decades. And those solutions, those are design patterns. And this slide right here just nails the concept. An algorithm, that's a recipe. It's a precise line-by-line set of instructions to get a result. But a design pattern is a blueprint. It shows you the overall structure, how the pieces fit together, and what you're going to end up with. But it doesn't give you the exact code. You have to adapt that blueprint to the specific project you're working on. So just to really hammer this point home, let's be super clear about what a pattern is not. It is not your high-level system architecture. It's the clever solution inside one of those boxes. Like we just said, it's not a step-by-step algorithm. And this is a big one. You can't just npm install a design pattern. It's a concept, an idea, that you have to bring to life in your own code.
Okay, so if these are concepts we have to implement ourselves, what are the guiding principles? Well, this gets us to the philosophical heart of it all. If you only remember one thing from this whole explainer, please make it these 2 golden rules from the legendary Gang of Four, who literally wrote the book on this stuff.
All right, here's the first one. I know, it sounds a little academic, but trust me, the impact of this is absolutely massive. Program to an interface, not an implementation. So, what does that actually mean? Okay, here's what it means in the real world. Instead of your code knowing that it's talking to a very specific SQL database, it should only know that it's talking to something that acts like a database. That abstract contract, the interface, means you can swap out that SQL database for a test database or some fancy new cloud database later, and the rest of your code doesn't even notice. It's kind of like a USB port. Your computer doesn't care if you plug in a keyboard or a mouse, it just knows how to talk to the USB standard. That port is the interface, and it is the absolute key to building flexible, future-proof software.
And that leads us right into the second golden rule, which is just as powerful. Favor object composition over class inheritance. This one really gets to the core of how we should be reusing our code.
And this shows the 2 approaches so well. Inheritance, what they call white box reuse, is super fragile. The child class is totally tied to how its parent works on the inside. So if the parent changes, guess what? The child breaks. But composition, black box reuse, is way more robust. You're just putting together independent objects that talk to each other through stable interfaces. They don't need to know each other's secrets, and that makes the whole system stronger. Think of it this way. Inheritance is like being born into a family. You get all the traits, good and bad. Composition is like building with Legos. You pick exactly the right pieces you need to build whatever you want. So, we have these amazing guiding principles. But how are all these different patterns organized? It's not just some random grab bag of tricks. There's actually a map to this whole world. So all patterns basically fall into one of 3 buckets. First, you've got creational patterns. Think of these as the factories in your app. They handle how objects get made. Second are structural patterns. These are the architects. They figure out how you assemble different objects into bigger, more useful systems. And finally, you have behavioral patterns. These are the traffic cops, managing how all these different objects talk to each other and get work done. You don't need to memorize this chart, just know there's a logic to it.
But, with all this power comes a lot of responsibility, and that brings us to our final and maybe most important section, some real-world wisdom about how to use and how not to abuse these tools.
First up, this is a huge insight. The code you're looking at in your editor, all those static files, that's not the real application. That's just the compile time view. The real application only exists at runtime, when it's this living, breathing, sometimes messy network of objects all talking to each other. Understanding that difference is a massive leap in how you think about architecture. And patterns are what help us design for that dynamic runtime reality.
All right, now for the words of warning. First, you got to avoid the hammer and nail problem. When you learn a cool new pattern, suddenly everything looks like a place to use it. But sometimes, you know what? A simple function is still the best answer. Second, you have to realize that some of these classic patterns are really just clever hacks for features that were missing in older languages. A modern language might give you a much cleaner way to do it. And finally, and this is the big one, you can't master this stuff just by reading. True understanding only comes from experience, from building things, seeing them fail, and learning from it.
And when you boil it all down, this is the real secret power of design patterns. It's not just about the code. It's about having a shared language. When one developer can say to another, hey, let's use a factory pattern for this, they've just communicated a huge amount of complexity, trade-offs, and design intent in one single phrase. It's an incredible shortcut.
And that really brings us full circle. Learning this vocabulary, internalizing these concepts, it's about making a fundamental shift in your craft. It's about taking that crucial step from just writing code that gets the job done today to architecting software that is elegant, flexible, and truly built to last.